Flack math! Give me some math and I'll give you some flack. Flack math!
Usually in science, a lot of times in science, numbers are either really big or really small, okay? So instead of writing a bunch of numbers with a bunch of zeros, then it's easier to write it in scientific notation. Scientific notation, numbers are always in between 1 and 10. That's kind of manageable. I can multiply numbers that are in between 1 and 10. Now if it's like 3 billion, it would be 3 times 10 to the 9th power. But it's still, you're still dealing with that 3 instead of the 3 billion, okay? So it makes it a little bit easier and manageable. All right, so 51. Scientific notation. So today, or this week, we just have these lessons due. Next week, we'll do the same kind of thing with no test next week. So it'll be a couple weeks before we have another test. Okay, so look at this number. Can anyone say this number?
No.
Do you know how to say it? Dylan, were you raising your hand? Hunter, you got it?
9,461,000,000,000.
Perfect. Good job. All right, do you know what this number represents? Do you know?
Does it represent kilometers?
It is kilometers, but this is a light year. Do you know what a light year is?
I like year.
Anyone know what a light year is? Besides an action figure? Yeah.
Is it like a year in space?
Kinda. Do you know, Grace?
Is it the amount of time that it takes light to travel? Or
Close.
From a place to a place.
So close.
Things like that.
Anyone else, Marion?
how much light travels in a year?
Yeah, so basically, this is going the speed of light, how far it goes in a year. Now, it just seems like it'd be a lot more, doesn't it?
Yeah.
So, but that's a light year. Now, I don't want to write all those zeros all the time. So here's what I'm going to do. I'm going to change it to scientific notation. So there's just 2 steps. And you can write them down if you want. But this is scientific notation. Step 1, put decimal after first non-zero digit. Okay, I have to say non-zero here because just like we deal with really big numbers, a lot of times in science we deal with really small numbers. So fraction of a fraction of a fraction of a number. So it could be like 0.00000073 or something. Okay, so the first non-zero digit is what?
1.
Nope, what's the first non-zero digit in this number? Not just in general. Carol?
9.
9, so I'm gonna put it right there. 9.461, and then I'm not gonna include all these zeros, right? Because you can drop off zeros in a decimal. Now, are those 2 numbers the same number? No, so I have to make that blue number equal that. Do you know how to do that? Do you remember how to do that? We talked about it.
0, 0.
How do you move the decimal? What do you have to multiply by?
3.
Hunter?
It's about 10.
It's 10 to move it 1 to the
Yeah,
right.
if you move it 1 to the right, then you multiply by 10. If you want to move it 2 to the right, you multiply by 100 or 10 squared, right?
Yeah.
So see how the exponent corresponds to how many places you move it. So what exponent do I need to move it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now these numbers are the same. Okay? So step 2, multiply by a power of 10. That will return the decimal to its origin, to where it started. Okay, so see how it started here. If you don't see a decimal, it's on the right. So how do we get this decimal back to the end? We have to multiply by 10, 12 times. Because when you multiply by 10, the decimal goes to the right. But you want to multiply by 10, 12 times to move it 10, 12 places to the right. Does that make sense?
Yeah.
Okay, so it's really not, it doesn't feel like math because you're just moving a dot across the page. That's it. Multiply by a power of 10, that will return decimal to its starting place or origin. Okay. So let's see if, so that's going, changing a standard notation. This is standard notation, and this is SINOT, scientific notation. So let's see if we can go the other way. The other way is easy because you're changing from SINOT to standard notation. So I want to change this number to standard notation. How do you do that? I just want to make it a normal number. I don't want a scientific notation. Grady?
You move the decimal 6 places.
Yeah, you just move it 6 places. You do what it says. That's how you change scientific notation to standard notation. Do what it says. It says move to the right 6 places. 1, 2. No more digits. What do?
Zeros.
Add zeros. So you need 4 more zeros, right? So let's see. 4, 6, 2, 0, 0, 0, 0. Looks like 4,620,000. That's not too bad, right? The going from standard to scientific notation is a little backwards. And that's what we'll be doing a lot of in math. A lot of backwards thinking, especially when we get to algebra. A lot of backwards thinking. Okay? So why don't you guys try this on your own? So let's do this number. Change that to scientific notation.
Mr. Flack,
Mm-hmm.
did you just count the zeros that don't have
Nope.
to see the 10 or just like all the numbers next to the decimal?
You gotta move, if you just count the zeros, then you'll get it wrong because you have to put the decimal after the first non-zero digit and then multiply by whatever will get it back to where it started. Okay, do you have an answer, Hunter? Okay, hold on to it.
Mr. Flack,
Mm-hmm.
does it say 405,000?
405,700,000, yep. All right, Hunter, what'd you get?
4.05 times 10 to the 8th power.
Okay, don't forget the 7. There you go. Times 10 to the, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Good. Okay, can you remember those 2 steps? All right, it gets tricky when instead of a number like this, you have a weird decimal number in the first place, but that's okay. So what do you think is bigger? What do you think is bigger? Here's example 3. You might get problems that look like this. 1.2 times 10 to the 4th or 2.1 times 10 to the 3rd. Which one do you think is bigger? The left or the right? Hunter knows, Grace knows. What's your gut tell you, Grace? Which one's bigger?
That the one to the right.
You,
No, the
you're
one to
pointing
the
left
No, to the left.
and
Sorry.
saying right.
The one
Okay.
to the left.
Yeah. So because if you were to change this to standard notation, it'd be 1, 2, 3, 4. Okay. And this one would be 2, 1, 2, 3. So 2100 is not as big as 12,000. So see how this doesn't make sense. It's kind of like when you compare fractions and they have different denominators. Well, get the same denominator first. Well, change them both to either standard notation or scientific notation. Ooh, I'm gonna taste that later. Okay, so first of all, scientific notation, since it's always after the first non-zero digit, this is gonna tell you which one's bigger. The exponent's gonna tell you. This could have been like 9.9 times 10 to the third, and this could have been like 1.1 times 10 to the fourth. Okay, that 1.1 times 10 to the fourth is always going to be bigger because that exponent's always bigger. So if it's in scientific notation, then just look at the exponent first. And if they have the same exponent, then you start to look, okay, well, which one of these is bigger? Okay, does that make sense? Good enough? All right. So let's move on to lesson 52. Okay. All right, tell me as fast as you can.
Mr. Flack, we're doing lesson 5.
All right, we're going to talk. I'm not going to tell you what we're going to talk about first. I want you to tell me what this is first, okay? What is that? Quick, what is it?
Number.
Kiara?
Is it 18?
Nope.
Number.
What is it?
Is it 14?
Did all of you think 18?
Is it 14?
It is 14. Why is it 14 and not 18, Dylan?
Well, I multiplied
Yes.
4 times 3 first and then added.
Yeah, now multiplication comes before addition. And to prove it, you can change that multiplication to you can change any multiplication problem to an addition problem. Did you know that? 4 times 3 is just 3 plus 3 plus 3 plus 3, right? Or it's 4 plus 4 plus 4. So then you have 2 plus 4 plus 4 plus 4. So see how you have to do that multiplication first. So this is orders of operation. That's what we're talking about. Order of operations. So multiplication always comes first. Okay, so if you want to write this down, you guys heard of PEMDAS? PEMDAS, repeat after me. PEMDAS is stupid.
PEMDAS is stupid.
Yes, so I'm not, when you can write this down and then cross it out. Because this implies that multiplication comes before division. It doesn't. And this implies that addition comes before subtraction. It doesn't. They happen at the same time, that you just go left to right. So the better way to write it is like this. So you guys heard, please excuse my dear Aunt Sally? You heard that? So it would be, please excuse my dear, one word, Aunt Sally, one name, okay? So these two have to have, there's really 4 operations. There's 4 orders. There's parentheses first, always P first. It's a good rule in life. Before you go on a road trip, before you see a movie, before you do math, parentheses first. Exponents or roots come next, and that's the same thing. It'd be exponents and roots. Multiplication and division, and then addition and subtraction. So in this case, multiply first, and then add 2 plus whatever you got when you multiply it. So we're going to do a couple examples, and then we're going to call it, okay? Because this is a pretty easy concept. It's just something you have to remember. Yes, Hunter.
When you had asked what that was at the top, I was literally about to be like, the Pythagorean theorem.
Yeah, well, that would have been weird.
Yes, I know. Because I completely forgot it was called the order of operations.
Yeah. Okay, so first order of operation is parentheses. But we're not going to talk about parentheses yet. So, but I'm just going to put them there just so you have them. So parentheses. Or you can write this down too, same thing. And then exponents and roots, or powers and roots. 3, multiplication and division. And then addition and subtraction are the lowest guys on the totem pole. So you do that last, addition / subtraction. Okay, so let's do some examples. You ready? Here's example 1. Do that. If you do it in your head, you can do it in your head, but it's a little risky. So I wouldn't do this in your head if you're taking a test or anything like that. I have a method that I use to do these just to be safe, but if you have your own method and it works for you, then stick with that. Grace has got an answer. Anyone else? Hunter, Kiara, Evie, what'd you get? Okay, what'd you get?
32.
What'd you get, Hunter?
12.
What'd you get?
12.
What'd you get, Grace?
16.
Okay, lots of different numbers. So here's what I'm going to say. Make sure you're confident in your strategy. If you're not, use mine. Here's my strategy. I'm going to underline what I'm going to do first. So look at the whole problem and tell me what I want to do first.
4 times 3.
4 times 3, and what else?
45 by 2.
Yep, so do those first. This is multiplication and division. Remember, it happens at the same time.
Oh, I did something wrong.
Okay, so if I write, what's 4 times 3?
12.
So I'm going to put 12 under that. What's 4 divided by 2? 2. Everything else that I didn't underline, I'm going to copy down. 2 plus 12 minus 2. What's 2 plus 12 minus 2?
12.
12.
Darn it. I did plus instead of minus. Yes.
Okay, so do you see how it's confusing, especially if you do it in your head and if you're doing things out of order? It's really easy to do things out of order, so don't do it.
Okay.
I mean it.
Okay.
Stop it. Okay, what about this? 3 squared plus 3.5 all over 2. What? And technically this little division bar there, that's considered a parenthesis. So basically it separates the top and the bottom into parentheses. So you got to do the top and the bottom separately first, and then the last thing you do is divide. Hunter's got an answer. Who else? Got an answer? Okay. Who else has got an answer? You got one? You sure this time?
Yeah.
Didn't work out last time, did it? All right. Hunter, what'd you get?
12.
Okay, what'd you
I
get?
got 12.
What'd you get?
12.
Anyone else get anything different?
I got 12.
Okay, let's check it out. What's 3 with this little 2 there?
Oh, 3 times 3.
Yeah, which is 9, right?
No.
So that's what we're doing. I'm not going to touch anything else. So I get 9 plus 3.5 all over 2. What do you do next? Multiply, right? So what's 3.5?
15.
So this equals 9 plus 15 all over 2. What do you do next?
Add,
Remember those are
divide,
parentheses, right?
add.
Even though division comes before addition, right? But these are in parentheses, so you have to add next. So this 9 plus 15 is 24, all divided by 2. That's the last math problem, which is 12.
I was gonna say it.
All right. Does this feel okay? All right, now this is, so your homework is going to add one more thing to the mix. It's going to start with variables, but that's okay because variables can be assigned value, and that's what's going to happen. So when you see the directions evaluate, evaluate just means substitute the variables for numbers and solve it. Okay, so if A equals 3 and B equals 4, what's the value of A plus AB? What does it mean when A is right next to B? Alan?
34.
No, it does not mean that. So I'm glad you said that because a lot of people think
Oh,
in
multiplication.
multiplication. Good job. All right. Do you have an answer, Hunter? Anyone else have an answer? Kiara, you have an answer? You guys got one? Did you do it in your head?
Yep.
All right. It's risky business. So what'd you get, Grady?
15.
What'd you get, Kiara?
36.
What'd you get?
15.
What'd you get?
15.
Okay. Do you see why Kiara got 36? Why did Kiara get 36, Alan?
Because it was 8 plus B, so she did 34 instead of multiplying.
Yeah. Instead of
by 4.
multiplying, you just
Yeah.
put them together. Okay. I'm glad you did that. So now you'll never do it again, right? Promise me. I'll never do it again. Say it. I'm just kidding. You don't have to say it. Okay, so you're just substituting that in. So when they're right next to each other, when you can write letters next to each other in math, that always means multiplication. When you write numbers next to each other, that doesn't mean multiplication, right? But letters right next to each other means A times B. So this is 3 times 4, not 34. So and then you got A there, so that's 3 plus 3 times 4, right? So what'd you get?
I'm just saying that the A times B above it
Looks like subtraction.
Yeah.
Huh? Okay, better not. Thank you. Okay, what'd you get, Grady?
What?
What was your answer?
15.
Okay, is that what you guys got?
Yeah.
Does that make sense? 3 plus 12, final answer 15. So this is what they're going to do. They're going to start with variables, which is okay as long as they give you what the variables are. That's easy. You just substitute those in and then do the math. Can you handle that? Okay, good job, guys. That's all I got. Congratulations.